Hello everyone. In this session, we will discuss revisiting irrational numbers. Well, we are now all familiar with rational as well as irrational numbers. We know that irrational numbers are the ones which cannot be represented in the form of p by q, where q is not equal to 0 and p and q are integers. We also know that the decimal expansion of the irrational number is always non-terminating and non-recurring. For example, if I take irrational number pi, which is equal to 1.1415926 and so on. Similarly, root 2, which is equal to 1.414213562 and so on. You can see here that this decimal expansion is always non-repeating as well as non-terminating. And if I find the value of root of p, where p is the prime number, then we will always get this value as irrational numbers. That means the root of prime number will always be an irrational number. And we will also know that the product of rational and irrational number is always irrational, except if the rational number is 0. Then the product will be 0. So in this session, we will discuss how we can prove the numbers to be an irrational number. So here, let us prove root 2 as an irrational number. Let us prove this by proof of contradiction. We will first consider root 2 as a rational number and then prove that root 2 is not a rational number. So if we take root 2 as a rational number, we have 2 as prime number. That means 2 cannot be further factorized. So root 2 can be written as p by q. That means it is an irrational number. So if I square on both the sides, I would get 2 is equal to p square upon q square. This can also be written as p square is equal to 2q square. That is, q square is equal to p square by 2. Now, from this equation, what I can understand is that if p square is divisible by 2, then p is also divisible by 2. That means 2 is the factor of p. Similarly, now if I consider p is equal to 2r, I would get this equation as q square is equal to 2r square upon 2. That is, q square is equal to 2 times r square. R square can be written as r square is equal to q square upon 2. Here we can see that q square is also factor of 2. That means 2 is also factor of 2. So here we can see that 2 is factor of both p and q. But this contradicts our assumption that 2 is the prime number. Means it should not have factors. So we can say that root 2 is not an rational number and it cannot be represented in the form of p by q, where p and q both are irreducible. So root 2 is an irrational number. Similarly, you can prove many examples to be irrational numbers. For example, if I take 3 plus root 5, 3 plus root 5 can be proved as irrational number. If I take this number as rational, I can write this as 3 plus root 5 is equal to p by q. Now, root 5 can be written as p by q minus 3. That is, root 5 is equal to p minus 3q upon q. So here we know that p, q and 3 all are rational number. Therefore, p minus 3q upon q will be rational number. But this contradicts that root 5 is an irrational number. Therefore, we know that 3 minus root 5 will always be an irrational number. From here, we can also say that addition of two rational number will give us the rational number. Addition of irrational number plus rational number will give us the irrational number. Product of two irrational number will also give us the irrational number.